Aitäh Taimar Alale ja liigume edasi esimese sisulise sõnavõtuga ja hea meel on tervitada siin saalis EUMETNETi tegevdirektorit härra Eric Petermanni. Please, you're welcome.
Thank you. Okay, this will not be in Estonian, I'm sorry. It's a difficult language for us. But then Finnish is even more difficult, I understand. So you see, you're not the only ones with this difficulty. But thank you for hosting me here, for having me over. I'm Eric Petermann, the director of a very unique organization which is called EUMETNET, which is the network of European weather services that collaborate together. And we actually apply an old Chinese saying that basically says, if you want to go fast, you do it alone. If you want to go far, you do it together. And this is what we're doing in EUMETNET. We're trying to go far to have sustainable programs. So yeah, okay, I use the arrow. So I wanted to, if it is at all possible, to summarize in just one diagram what a weather service does, what a meteorological service does. Of course, this is very schematic, but I think it's quite, it summarizes pretty well, maybe not completely extensively, but it summarizes pretty well what a weather service does. And if you look at these little arrows, which are the value chain, you will see that everything starts from observations, and you heard that in the initial slides or videos that were presented, especially with the centennial observation systems. All of that is fundamental. Observations is about 50 to 60% of the budget of a weather service. It's huge. And without this observation network, we cannot do forecasts and we cannot do climate. It's as simple as that. So the core business of a weather service, and its most expensive component, is dealing with observations. And these observations, of course, you will need to deal with observations at your national level, but you also cooperate with others at international level, because observation has been standardized thanks to our World Meteorological Organization. This organization is a UN organization, and it's very important in all of the standardization that is necessary so that everybody does the same thing in the same way. Otherwise, if you measure temperature in one way in Estonia and another way in Russia or in Latvia, it doesn't make sense anymore. And WMO is there to make sure that everybody is applying these standards. And it's not an easy task. So operating your national weather, your national observation system means that you have equipment that is deployed here and there in your country. And you have to maintain this equipment. You have to purchase it. You have to find the best value for money, etc. That means people, that means knowledge, that means know-how, that means training. All of that is important, and it's all in your Met service. You will be surprised to find out how much competency there is in your Met service. But of course, at the same time, and you of course know that, and Petri Talas repeats this every time, World Meteorological Organization, everything that is climate and weather related is global. You can't do this alone in your country, even if it's a big country. You can't do this alone without knowing what's going on with your neighbors and in other countries. And that's where cooperation comes in. We could not have, in Europe, for example, we could not have had all these fantastic satellites flying over our heads without doing this together. There is no country in Europe who has the capability of having a meteorological satellite program on its own. Even the Russians gave up. So, to give you an idea. So, the only countries that do that is Europe, because they have grouped together and created an organization called EUMETSAT to do so. There's the USA, China, Japan. That's it. So, these little birds that fly over our heads cost a lot of money. And so we have to be together to fund them. It's simple as that. And the European network, EUMETNET, which I have the honor of trying to lead, we have a lot of programs that we build together in observations. One of those is a very important program, which you don't see because it's all below, the iceberg, and then you have what's below the ocean. You don't see that. And that's the problem with weather service. There's lots of things you don't see. But there are a few things you do see. Among the things you don't see is that over the Atlantic, we have 18 that are sending balloons with radio sounds. And these radio sounds are measuring wind, temperature, and humidity in the atmosphere over the Atlantic Ocean, where there's nothing else. There's no continent, right? There's nobody. There's just ships that can sail there. And they measure. And who pays for that? Well, all of us together. Because we agree that all of us together, this has a benefit to all of us. Having observations over the Atlantic, all of the members of EUMETNET, 31 countries, agreed that this is a common endeavor. So that's important. And of course, Estonia is one of those. So if we go this way in the value chain, I will use other slides to go the other way. There's no hierarchy. It's not going down or going up. I had to present it in one way. From your observations, you can create databases, climate databases, do the proper quality control. All of that is a lot of work. It's people, it's science, it's all of that. From your observation network, you can create your weather service, and of course the Estonian agency does that, creates different types of services, climate services and products for various uses. And of course, in the climate change environment in which we're living today, this is all the more important because the politicians have to take decisions at one point in time. How do you adapt to such climate? It is not up to the Met Service to decide how to adapt, but it's up to the Met Service to explain the situation. And then the politicians make the decisions. And here again, you have a lot of collaboration between members and the countries in Europe, mostly through the European Commission, who has put a lot of money in climate services. But okay, I didn't put that on the slides. Now, what is important, and that you have seen on the right-hand side of this diagram, is that all of this is user-driven. Okay, a Met Service will not do things if there's nobody behind that to use it. It's always user-driven. So when you are going to design climate services, products and climate services, and you're going to disseminate that to the outside world, you have to make sure that somebody's going to use it. If nobody uses it, then it's no point doing it. So it's important to listen to your customers. Now, if we go the other way around the value chain, the observations are absolutely essential to make forecasts. And to make forecasts, it just doesn't come out of a magic box. It doesn't come out of a crystal ball. Of course, you can imagine there's a lot of technology and a lot of science behind that. And the weather services know how to use that science, know how to use that technology. And once again, they have joined forces to do things together. Once again, because the computers that are necessary to run what we call numerical weather prediction models, which is just a big computer that runs simulation of the atmosphere. All of this, you can't do it alone, once again. So back in 1985, our predecessors decided to group together and create one of the great successes of Europe, which is called the European Center for Medium-Range Weather Forecasting. And this European Center creates things like this. But this is multiplied by thousands and thousands of information of this type that everybody in Europe and everybody in the world uses. And this European Center is now the world-leading center. Nobody in the world does better than this center in terms of performance of numerical weather prediction. They're the ones who predicted that Hurricane Sandy would hit the US coast 6 days before. The Americans hadn't seen that. So this is to give you an idea of the quality of the scientists and the science and the technology that goes to ECMWF, the European Center for Medium-Range Weather Forecasting. And all of these people are Europeans. So, yeah, we do a lot of things in Europe, a lot more than in any other place in the world. And Petri Talas, he recognizes that. The people at WMO, Petri Talas, and all the others at WMO, when they see what we do in Europe with ECMWF, EUMETSAT, and EUMETNET, They say, wow, this is not happening anywhere else in the world, only in Europe. That's great. When you think that we've been fighting each other for centuries and centuries, and now we have this success, I think it's fantastic. It's worthwhile. So all of these numerical weather prediction systems and models, they create the necessary information that this weather service here, but it's the same in other countries, they will produce services, forecasts, or whatever you want to call them, that are necessary for various types of users. Once again, user-driven. This is the value chain. And one of those products and services that a weather service does best is issue warnings. This is I would say, the major reason why a weather service exists. It's the protection of people and property. Issuing warnings. This is this is in the DNA of all weather services. Yes, I have to be the best to be able to produce these things. And in order to do that, you need to master, as I said, the science, the technology, the know-how, the training, but you also need to understand the user needs and to understand that this type of information is important to the population and to your government and to different economic sectors of your country. So I had to wait a few days before I can see something different than just green. So I took this out of your website, of course, and I had to wait a few days because you had one point some nice weather. I mean, nothing really risky. Now, what's interesting with this type of map, this is not a forecast. This is not a weather forecast. This is a risk forecast. And conceptually, it's quite different. It's not a weather forecast. I'm forecasting the risk of the weather situation, not the weather itself. Very interesting. Think about that. This is called an early warning system. And you heard Petri Talas mention that word, early warning system. Our community, weather, hydrology, and others, have been working for a long time. And of course, in Europe, we are way ahead of the rest of the world. You wouldn't imagine how many countries are using this. Very little, actually. Very little are using this type of system to convey, to communicate the severity of a weather situation to the outside world, to the general public or to the authorities. There are very few countries who do that. It looks very simple, doesn't it? I mean, the concept is quite simple. You have a grade of colors to give you an idea of the severity of the situation. It's quite simple. But you'd be surprised, very little countries do that. But in Europe, we all do it, except for 3 countries. I mean, there are only 3 countries left who aren't doing it yet. I won't name them because I don't want to shame them. But it'll come. They are interested in doing something like that. And when we do something like that, not only do you do it at national level, but you also do it at international level. So there are quite a few challenges ahead for the weather services. I've seen that you have your own strategy and your own motto, but this one is valid for everybody. I would say helping your country be weather and climate prepared. That's important. It's about the outreach. It's about mastering the whole chain, the whole value chain that you've seen, from the observations to from the science to the technology, the observations, the numerical weather prediction, the climate databases, all of that, and of course the outreach. All of that is very well mastered by a modern Met service, and this one is a modern Met service. You can be sure of that. Now, as I said, you have to make sure that there are some users who can actually understand what you're producing. It's user driven. And if you're just going to issue forecasts saying, for example, it's going to rain 40 millimeters in 12 hours, well, technically, okay, you did a good forecast because it can be verified. We can verify through the different instruments that you will see that you did have 40 millimeters of rain in 12 hours. But then so what? I mean, what does it mean to you? 40 millimeters an hour of 40 millimeters of rain in 12 hours. Does it mean something to you? Well, it doesn't mean anything to 99% of the people, right? So in the future, and actually now, today, a weather service cannot be just satisfied by saying, I've issued a forecast of 40 millimeters of rain in 12 hours or 120 kilometer an hour winds. What does 120 kilometer hour wind, what does it mean? Is it dangerous for me? Is it dangerous for somebody else? Is it not dangerous? We don't. You don't really know. And so this is the next step in understanding user needs. Is you've created a forecast. You've mastered this whole value chain, this whole science and technology chain. Transposing this into what it means to the user. This is the next step. And this is the big challenge that the med services are up against today. So this is where the concept of impact-based forecasts and impact-based warnings come in. How do you communicate not just the forecast itself, but communicate on the consequences of the forecast, the impact? And this is the new challenge here. You will have different audiences, you have different impacts for the same forecast. So that's very interesting. So what's going on here? It's telling me I'm late? Okay. So as I said, when I suppose it was somebody from the government that was here earlier. Yes. So the Met Service is part of the decision-making process that the authorities will take. It's not the Med Services who takes decisions on evacuation and protection and things like that. It's civil protection, it's the government or whatever. But the Med Service is an essential cog in this system of collaborative decision-making. Okay, so in the future, what you've seen are these color codes. They will be used for impact-based types of warnings. And they will be multi-hazard. It's not just rain, not just wind, not just temperature, but a lot of other things. Landslides, all of this is now in question. We want to know what a weather phenomena will have as a consequence. And we want to communicate on these consequences. And these consequences could be multiple. And that's why we talk about multi-hazard warning systems. So this is the new keyword, multi-hazard early warning systems, MHEWS. This is the new keyword at WMO. Everybody talks about that now. It's the big keyword. And it's the big challenge of the weather services to be able to use the same type of framework, like these color codes, to communicate on different types of hazards. And that means partnering with a lot of people. A weather service cannot do everything alone. They have to partner with hydrologists. If you have landslides, you have to talk to geologists and people like that. So you have to partner with all sorts of institutions that also have science, that also have technology. So that is the future challenge. And of course, you have to know how the end user will use your information. You have to know how their processes work. This is another challenge. I talked to the weather people yesterday about that, but it's good that you know, as the public, that your weather service is going to be talking to other people. And that's important. Nobody stays in a silo. This is not possible anymore. Environment, earth science is become holistic now. You can't just have the atmosphere on one side and the sea on the other, or the landslides or geology as standalone disciplines. This is not the case anymore. Now the earth sciences is becoming holistic. That's very important. Then you have the source of information. And the quality of the information that you are using as a weather service or as anybody else, as any other authority that is issuing warnings, the quality of the source of the information that you're using is paramount. This is what will make the authoritative voice, what will make your credibility the highest. And being able to understand these sources and evaluate the quality of these sources is also a new challenge. Until now, the weather services have been using their own observation systems, their own instruments. They calibrate. They have all this technology, all of this this standardization for instruments. We have satellites. All of this is publicly funding. Now, this thing here is a weather station. It can measure pressure. It can measure temperature. It's a weather station. And there are millions of those out there. And we don't know what the quality of this data is, but the data is there. Facebook doesn't know the quality of the information that's out there, but it's using it and it's making a lot of money out of it. 99% of the stuff on Facebook is trash, but they make money out of it. It's incredible, right? So we can probably use the data that's in here or in your automobile, which also has sensors. Just the fact that your windscreen wipers are working means it's raining. That's information. Yeah. And we have to use this information. So that's what we call crowdsourcing. So it's important that we understand how to use that type of information. And once we understand how to use it and we use it well, our authority as a weather service is increased because we're using different sources of information. We have all the science and the technology and the big data processing and all of that. We master all that. And that means our authority is consolidated because we have, as a weather service, I say we, okay, because it's a community. We have in our DNA this mission. All the weather service strongly believe that this is a state duty, warning people to protect lives and property. This is part of our mission statement as civil servants, I would say, right? And most of all, it's one thing I like to say, a national weather service will avoid conflicts of interest. If you give the issuing of warnings to a private company, this private company will have the tendency to make the warning look even darker. So it creates more hype, more business. That's not our objective as a wet service. Our mission is to warn the people with authoritativeness and not with something behind our head saying, oh, I'm going to make business out of this thing. No, we can't do that. And that's why the warnings have to be issued by a public entity. I'm absolutely convinced of that. Okay, maybe it's old-fashioned, but I think it's very important. The conflict of interest is important. Avoid conflict of interest when you're dealing with protection of lives and property, especially lives. The single voice principle means that there are no 2 or 3 stories coming out here and there. This is why it needs to be a state mission. The state mission actually guarantees that it will be authoritative. Single voice means it comes from one source who is capable and who has the know-how, who has mastered all of the components of this value chain. And the Met Service has done that. And therefore it can be the single voice because it has all of the information and has gathered and verified all of this information. It's very important that the warnings come from a single voice and not from multiple voices. If you get a warning from the weather service and you get a warning from some other company and some other company, there will be conflict. And what happens then? It's going to be a mess, right? So you have to guarantee the single voice. It's up to the government to make sure that the regulation in your country and elsewhere make sure that this single voice principle is respected. Otherwise, multiple sources, multiple types of warnings, it will never work. It'll be a mess. And the Weather Service is the best place to do that because they have the mastership of all of that value chain, from the science, the technology, to the dissemination of the information to various user types. So, never blur the picture. Full control, well, I already said it. So this is in the thing. So the European meteorological infrastructure is very, very keen on cooperation. We have the national weather services. So we have 35 of them, some in Europe. 31 of them are members of EUMETNET. And around that, you have the World Meteorological Organization, which has its own Europe office. EUMETSAT for the satellites. I've already talked to you about that. ECMWF for the global numerical weather prediction. But you also have consortia of limited area models. The ECMWF makes a numerical weather prediction all around the world. But there are what we call consortia of various countries that have grouped together to make numerical weather predictions on a smaller scale, but a higher resolution. In other words, at kilometric resolution. Whilst the ECMWF model is at 12 kilometers, almost 10 kilometers tomorrow. But here, Aladdin, there are 2 kilometers or 1 kilometer, much better resolution. But of course, it requires a lot of power for computers. So you have to make a smaller area to be able to fit all that in the computer. You give us computer power, we know how to use it. We will use it. You multiply by 10 the power of the computers, we will know how to use that immediately. And then EUMETNET is the cooperation for different forecasting and observation areas. And then you have ECOMET, who Willie is here, for all that is regard to data provision and interface with the private sector. We don't pretend the private sector doesn't exist. We know it exists, and we know there's room for everybody. But when it comes to warnings, when it comes to the authoritative voice, this is a national Met Service mission. But everybody can do business. Everybody's allowed to do business. Thank God for that. This is what EUMETNET looks like today. So you see the 31 members, and we have some cooperating members who only participate in a limited number of programs. So we even have Moldova, you see. This is one of the examples of cooperation in Europe. So each country has its own system for the color codes, like you've seen for Estonia. But we can aggregate all that so you have a full picture of what's going on in Europe. So this is called Meteoroloogiapäev. I have a zoom right after that. Oops. There you go. It's better that way. And this is the situation a couple of weeks ago on the 1st of March. It was a very interesting situation because you even had some red. In the United Kingdom, they hadn't seen 40 centimeters of snow in 25 years. Oh, that was red. Oh yeah, it's red. 5 centimeters of snow in Paris is red. But 20 centimeters of snow in the eastern part of Estonia, I don't think it'll be red. You see, that's the difference between a forecast and the impact. That really illustrates things. 5 centimeters of snow in Paris is hell. Absolute hell. So that's why this color code is not as simple as it looks. It's a very intricate system. The criteria are going to be different from region to region, depending on how you're used to a weather situation. In the south of France here, you have a local wind, which is called Mistral. This local wind blows along the Rhone Valley. It's because of the orography, right? And this wind blows at 100 kilometers an hour very often. You go to another place in France, and you tell them there's a 100 kilometer hour wind. For them, it's exceptional. So you will not use the same criteria in the northern part of the country for 100 kilometer hour wind compared to the south, where it's something that happens every 2 days. So once again, a forecast is one thing, the impact is another. And that's where this color code comes in. It's very interesting. Well, here's some of the other things that we do together in Europe. We work on weather radars and create a map of all the radars in Europe. So there are 180 of them. We try to create what we call a composite or a mosaic of all the radars in Europe at one point in time. And this can be animated, of course. We also have a program where all of the sea surface observations are managed together. So here you have ships that are sailing across the Atlantic, but you also have here in red drifting buoys. So they just drift in the Atlantic, and they have sensors for temperature and pressure. And we just drop them in the Atlantic, and then they live about 18 months. Here you see some ships that you can bet they're fishing cod here. You can see it. And you have some ships like you have ships in the Baltic, ships in the Mediterranean. This is a program, this is airplanes. So these are airplanes. Airplanes have sensors aboard. They can measure temperature and wind and things like that. And we get this information from the airlines. And we use this information for our numerical models. All of this is shared by the 31 members of EUMETNET. So everybody pays his share to get this type of information that we know is valuable for everybody. So these are what we call AMDARs. These are readings, measurements from aboard airplanes, aircraft-based observations. Okay, that's it. Those are some of the examples of the cooperation. And of course, the big message is that your Met Service has the authoritative voice. and will do everything in its power to make it even better and more authoritative. Thank you very much.
Suured tänud Eric Petermannile.